Okay. We're going to look at a question that talks about the number of possible outcomes. It's also known as like counting techniques, and we can use a tree diagram. So let's say, so for a coin is flipped 4 times. Okay. What is the total number of possible outcomes? Sorry, I should have wrote that first. I apologize. Anyways, we read it as it wrote it. So what's important here? Well, we know we have a coin, so we'll highlight important information. A coin is flipped. And when they say flipped, essentially what they're telling you is a coin, it's a very small cylinder. That's not what I wanted to use to draw that. There you go. A coin. Oh, I can get rid of that. Yes, I can. A coin, so it has a face, and then it kind of has like another face. Sorry, it's not really my thing when there's that there. But essentially we have a face. You have a heads and a tails to your coin, right? And when you flip it, you either get one side or you get the other side of it. So the number of outcomes are 2. There are 2 possibilities, 1, 2 for a coin. And here it's telling us that it is flipped 4 times. That's actually really important because that is going to tell us how many possible outcomes we can get. So if we look, we're going to start by drawing a tree. So let's say we start with our very first coin. Keep doing that. We can either get a heads or a tails. Wonderful. Then, depending on what we get, we flip the coin a second time. And I'm going to shrink this a little because it's going to get a little larger, this tree. We flip it a second time, we can get heads or tails if we landed with heads first. Or if we got tails first and we flip it again, we could get heads or tails again. So what you're going to notice is this tree continuously start branching and branching depending on the number of flips. So this one represents our very first flip. And you can also numerically calculate this by just saying, okay, how many outcomes are there? There are 2 possible outcomes. And how many times did we flip it? So the possible outcomes is the base of an exponent, and the number of times we flipped it would be the power. So if we only flip it once, 2 to the power of 1 gives you 2 possible outcomes. If we flip it twice, well, there's 2 possible outcomes, and we flip it twice, well, 2 to the power of 2 is 4. That makes a lot of sense, right? We have 1, 2, 3, 4 outcomes. Great. In our next one, I'm going to write heads and tails a bunch of times. Okay. And our next one, this is our 3rd attempt at flipping. The base is 2. There's 2 possible outcomes. There are 3 attempts at it. 2 to the power of 3 is 8. And then we could do the next one. I'm not going to write them all out. It's going to take me quite a long time. But we know that this is, again, 2 possible outcomes to the power of 4. Well, that is 16. So in this case, if we flip it 4 times, our answer is there are 16 possible outcomes. You can do this with any random device generator. So imagine we had a die. Okay, it's a cube, and cubes got 6 sides to them. So if we were to do it just one time, 1, 2, 3, 4, 5, 6. You have 1, a 2, a 3, a 4, a 5, or a 6. That's the possibilities of one roll of a die, right? So there are 6 possible outcomes, and that's one roll. If you were to do 2, you'd have to do 6 branches from each of these. Oh, very nice. And you do 6 to the power of 2. So depending on how many times you roll a die, you can get a very different number of possible outcomes. Okay, so this is the formula. You can either draw trees, or you can use your numeric base and power to calculate how many outcomes there could be.